Starting out in 5.2, still solving systems by substitution or graphing. Nothing new today. A little bit of story problems, but we're just going to step it up a notch on this one because it's got fractions in it. Since they say solve by substitution, I should have an equation where there is like a variable all by itself. In this one, don't both of them have y by itself, right? Remember, it doesn't have to be y, so let's do a box around here. And where would the parentheses go in the other equation? Around y. Cool. Does the parentheses really matter? You know, we're getting a little bit better at that. Is there a number in front of the y right here that would be distributed through or anything? So I still like to put the parentheses in here, but when I substitute in, I know I actually don't need them since there was not a number in front of there. So it's up to you if you want to do that or not. But here's our nasty little problem. Fractions all over the place. So what we'll do is make them go away. There are two different denominators on there, right? Isn't there a 2 and a 4? Pick on the big boy, right? Isn't 4 the big one? Does the other denominator, is he like a multiple of that by chance? So cool. What we can do is throw this whole mamma jamma in parentheses and take everybody times 4. Right? Well, that will clear the fractions out. So remember, it's been a while, but we ask ourselves this. Do you see this green 2 that I have right here? How many times does this denominator go into 4? How many times does 2 go into 4? Twice. Then take that times your numerator, and would you believe you would get a 2 out of that? But there's also an x with it. I'm going to do that one more time, just real quick. 2 went into 4 twice. I took it times the numerator and still got a 2, and there was an x next to it. Cool? Distribute into 4 through this. This would be minus 20. The equal sign's right here. And then same question again. How many times does 4 go into 4? Once times the numerator. It would be a negative 3. And there's an x with it. And then the last guy, for some reason, gets forgotten a lot. It's not a 10. Shouldn't it be a 40? Are you with me on that? You got to distribute. Isn't that red line so much nicer looking than that original line that I had right here? Because I cleared the fractions. Please solve it for x. So I'm going to add the 3x over here. And then I shall add 20 to each side. And then we will divide that out. 60 divided by 5. I got 12 on that. Are we cool? Sorry, sometimes I go a little fast. Are we cool with getting x to be 12? That's half our answer, but I will tell you this, we will get one solution because the x's are still there. Like they didn't all disappear, right? So, all right, so we'll sub this guy back into the box. I can do that probably pretty simple because it's half times 12. What's half 12? 6, take away 5, which is how much, baby? 1. Ordered pair, 12, 1. Classify him. Is he consistent or inconsistent? Consistent, because we got an answer, and independent. Those could be the $1,000 questions. Also on an ACT, one single question. Hey, is this system consistent or inconsistent? You know, and that's just a simple thing. If you've never seen it before, you would have no idea, right? But since I talked that language to you, I hope you could get that question right. So let's do it again. They want us to solve this next system by substitution. Which line, top one or bottom one, should the box go around? Bottom one, because that's where y is all by itself. And doesn't the parentheses go around y upstairs? Remember, it doesn't always have to be a y. It's just whichever one had the variable all by himself. So if we do well on this, we'll call it a good and go to the story problems after this. So let's take what's in the box and put it in parentheses. And I'll just do that for fun. I'll put the parentheses. You're rewriting the entire original line, but where there was parentheses, we put what was in the box. Parentheses really didn't matter because there's no number outside of it. But what I do want to do is get rid of this stinking fraction. It's the only fraction in the entire thing also, right? There's only one fraction. So I want to get rid of the denominator. How do I get rid of that? Divide by 3. Take everybody times 3. So boom, boom. And then this 3 times that 3, like cancel each other out. Are you cool with that being a negative x? And then don't forget, it needs to get distributed to every other nugget. So everything has to be times 3 to keep that rocking and rolling balanced. And then the old danger zone of these x's, if they're on the same side or different sides, bless you, those are totally on the same side of the equal sign, so combine them together. Combine like terms. A negative x plus a negative 9x is a negative 10x. And keep on keeping on. So subtracting 15, I'll get a 30 over there. And then I'll divide by a negative 10. And now I know I got a solution, right? I totally will have a solution because there's still x's. There's still letters with it is what I should say. There's still letters. To find the other guy, put him back in the box. Right? Put him back in the box. So y will equal, negative 3 times negative 3 is positive 9 plus 5 mer. So as an ordered pair, if I graph those two lines, they would totally intersect at negative 3, 14. And that should be consistent because we got an answer, and independent because there's only one answer. But the whole point of putting these two on here was just to deal with fractions. Are you cool with what we do? We'll substitute, right? Then clear the fractions. In all my years' experience, I've seen students try to clear the fractions first, then substitute. Substitute first, like the box in the parentheses. Do the substitution, then clear the fractions. Cool? All right, so let's skip the next one and learn what these stinking systems are all about. Real life scenario of comparing situations that maybe we would have in real life. So basic one to start with, Steve and Dave are saving their money. Steve started with $240 and is saving $20, watch this, per month. Underline or highlight if you'd like to. $20 per month. Why did I find that to be a special thing? The word per was helpful. $20 per month. Did you see the word per in there? Then Dave started with $305 and is saving $15 per month. You can maybe highlight that again as well. So they ask us to, one, define our variables. I'm kind of going to skip around a little bit because I've got some math sense that helps us define our variables. Like if we was to make a graph out of this, would you believe like on the x-axis there would be a label and on the y-axis there would be a label? And the two labels have to do with what's in here. This is our slope situation. Per is like the fraction bar. So if you would write this off to the side, $15 per 1 month, are you cool that I made that a fraction instead? And I've got some labels involved with that. What's the label upstairs? Dollars. What's the label downstairs? Those are our two variables, right? Is when they say define the variables, we're talking about dollars and we're talking about months, right? But which one's x and which one's y? It's really helpful if you can remember how to find the slope between 2 points. When I do m equals something minus something over something minus something, do you remember which letters were up top? The x's or the y's? The y's were up top, and aren't the x's on the bottom? It's like y2 minus y1 over x2 minus x1. Remember all that stuff? So guess what variable or what label y gets on it. Who's upstairs? Well, not 15, but what's the label? Dollars is what y is about. Are we cool with that? And guess what x is about? Months. It also goes back to my little philosophy that almost 99% of the time isn't a unit of time, the x value, right? Months is time. So x is going to be this, you know, like time in months, and y is going to be the amount saved in dollars. And we're going to be accurate with this, right? You know, so x is time in months, and y will be the amount saved in dollars. And then we'll bring in a new concept, even though we've done it a little bit before, domain and range. We haven't done it with a story problem. But you remember when we make the little bubbles, you know, domain and range, and we like draw the arrows and all that stuff? Remember those guys, those mappings? Domain is fancy for what your x's could be, and range is fancy for what your y's could be. But what they're really asking us is, what kind of numbers work for these? You know, like we got positive numbers, negative numbers, 0. Are you with me on that? So let's talk about time. Which kind of number makes no sense for time? Time can't be negative. Are you with me? I know in a concept it can. It's like, well, we can go back to the past, right? But when they are saving money, would you believe we're not going to have any negative amounts of time? Are you cool with that? So negative amount of money is out, right? How about zero? Is it possible for a human being to have zero money? Yes or no? Yes. Many of you might have zero money, but that could be false. It's like, well, I got $10, you know, but isn't it humanly possible to have $0, right? But it is not possible to have negative dollars unless we get a loan and things like that. But in this scenario, here's what we're doing. Let's talk about the money first. Let's do range. So we're going to say y can be greater than or equal to 0. Would you believe a person can totally have a positive amount of money? A person can totally have $0, but we're just trying to say we're not going to have negative amounts of money in this situation, right? The amount of money will not be negative, right? It's got to be greater than or equal to 0. How about the time in months, right? Time in months. Can there be positive amounts of time? Yes or no? Can there be 0 time? That answer is actually yes. That's immediately when you start. Like time was 0. As soon as they started saving, that is a 0 time, right? Like if I wanted to run a race, right now, right before I start, 0 time has passed, right? And then as soon as I start, the clock hits, right? So you can have 0 time. Can you have negative time? Nope. So what letter should we use for domain, X's or Y's? X, greater than or equal to 0. That's fancy talk to say that the time can't be negative and the money can't be negative. Are you with me on that? So, cool. Write 2 equations for this situation. I want to put their names by them just for fun, you know, to kind of get this easy. So let's do this. First scenario, like, is Steve right here. Steve started with $240 and is saving $20 per month. I've already discussed that that $20 per month is like the slope. Are you with me on that? What do you think that $240 is? His initial starting value. That's like the y-intercept. Cool. So let's do this. Let's go Steve. Right? And homework will ask you that. They'll say, write an equation for Steve. You know, so it's like, all right, so here's Steve. How about y equals 20x plus 240? Are you with me on that? Steve started with $240. That's the y-intercept. And he is saving $20 per month. Human beings would probably rather it be like 240 plus 20x, but I'm not a human being. I'm a math teacher. I want 20x first because that's your slope, and then the 240 second because that's your y-intercept. Are you cool? So how about a Dave equation? Do we know the slope for Dave? Yeah, what's Dave's slope? 15, so there's got to be an x next to it. And doesn't he start with 305? And to make this like sink in a little bit, before we do the math, because I think you see what we're going to do for the math, let's just talk about it. Who started with more money? Dave's got more money to start with. Are you with me on that? But who's saving more money? Steve. So like, should Steve catch up to Dave if they keep going? And they're asking this, after how many months will they have the same amount? Well, what you do is you solve a system of equations to figure that out. And how would you solve this? Well, graphing wouldn't be that bad if I had a graph, right? But they don't provide me a graph. Are you with me on that? So how about we do it, since there's a variable all by itself, how about we choose substitution to do that? So we'll do a box in parentheses. How about we put a box around that? And what could we substitute that into in the other equation down below? Then for y. So let's take what's in the box and put it in the parentheses. Wouldn't that be 20x plus 240? Parentheses don't really matter. Equaling 15x plus 305. And that's pretty nice because there's no more y's with it, right? We just got it down to x. So let's solve that for x. I shall subtract 15 from both sides. And I'm going to need to sneak my little calculator out of here because I want to take 305 minus 240. But it's 65 though. You'll need a calculator today, my friend, so if you didn't grab one, go ahead and grab one. So 5x equals 65. And then what do you finally do to finish that off? Do what? Divide by 5, right, to solve for x. What did you get when you take 65 divided by 5? 13. We need to put a label on that. And the cool thing is you've got those labels figured out already. This is x. If you go back to where you defined your labels, what is the label that x goes with? Months, right? It will take 13 months. Cool. But here's the weird part. That's not really what you do when you solve a system. That was half the answer, right? How do you find the other half of the answer? What should we do with that 13? Don't we substitute it back in to find the y value? What will the y value tell me? How much money they had, right? Isn't that what y stands for? So let's put that back in there. Let's take 13 and put it in the box. You can do that all in your calculator if you wanted to. It's 20 times 13 plus 240. And how much money will they both have? $500 dollar bills, y'all. So Dave started with 305 bucks, but he's just saving 15 bucks a month. Steve had less money, but he's saving 20 bucks a month. And if they kept that up and nothing changed, after a year and a month, aka 13 months, they would have the same amount of $500 in their accounts. Are we cool with that? It's a pretty basic one. So let's try another one. Yolanda and Rita are saving their money. Yolanda started with $50 and is saving, helpful hint right here by the word per, right? $8 per month. Rita is saving $7 per month. Why did I find the pers? Because that's our slope, and if you write it as a fraction, as the first number over the second number, it tells you what the labels are for your variables. Y's are always upstairs, and X's are always downstairs. So it's the same situation, just with different people here, right? Is an X time in months, and Y is the amount saved. Cool? The domain is about what kind of numbers make sense for months, right? Positive, negatives, or zeros, right? You know, so which numbers don't make sense? The negatives. So we're going to say that the time in months, instead of me writing that all out, I'm just going to put X, because isn't that what X stands for, time in months, has to not be negative. And the fancy way to say is greater than or equal to 0. Cool? How about the amount saved? Positive, negative, or 0. Which numbers don't make sense? Negative. So I'm going to say the amount they have saved, but I'm just going to write Y, because that's what we're letting Y stand for. Y stands for the amount they have saved. Can't be negative, greater than or equal to 0. Cool. Let's write two equations. Put their names next to them also. So we got us a Yolanda. She's a very popular lady in this class. Yolanda, check your equation with mine. For Yolanda, and if you're good with that, get you a Rita equation. The amount they started with is the y-intercept, and what they're saving is the slope. And it's another situation again. As we get smarter, we can see if they can catch up or can't catch up. Let's see if they can catch up. Who started with more money? Rita. But who's saving more money? The other person, right? So the other person will catch up. But if Rita started with more money and is saving more money, would you believe that other person could never catch up? Are you with me on that? It's like you got to just find the balance here. So these should intersect. You know what I mean? They should intersect. I don't want to graph them, though, because I don't have a graph. So let's solve the system by substitution. Because we got a variable all by itself. So 8x plus 50 should equal 7x plus 55. Solve that for x. Pause the video. Get that done. So I solved and got x to be 5 months, and then to figure out how much was in their account, I shall substitute 5 back in, and I'll get 8 times 5, which is 40, plus 50 more, isn't that $90? Is that correct? How does that seem to you? Seem okay? I won't lie, those are basics, right? These are basic story problems, but it's just to get the point across. Like, what are we doing solving a system? We had two variables that we didn't know either one. Having one equation all by itself doesn't matter, but whenever they ask when they are the same, that is like when they intersect, if we was to make a graph on it. So let's get a different story problem, right? Lauren is buying tickets for an online concert to a Miley Cyrus concert. Miley is amazing. She looked online and found two reasonable deals. Welcome to real life. Soon, someday, you will probably go shopping for tickets or something, right? You know, where do you go? Online, and there'll be different deals. It's like, which one should we buy, right? Two different deals. The first one on StubHub charges her 65 bucks a ticket, but there's this online order fee of 10 bucks, right? Could you tell me real quick, just first tell your neighbor, which one's the slope, 65 or the 10? It's real easy when you know the magic word. What's the magic word? per, right? So, boom, $65 per ticket. Underline / highlight that, right? But the second deal is not on StubHub, it's on Ticketmaster. $63, ooh, tickets are cheaper, tickets are cheaper, tickets are cheaper, right? But what's the catch? $20 online fee. Are you with me on that? So it's like, decision time. Hey, what's the decision? So it's all about knowing how many tickets you need to order. But before we get there, let's define our variables. It's right here, dog. $65 per what? Per what? Because it's not months this time, it's what? Tickets. Isn't tickets the label that was downstairs? Which one of those is Y, upstairs boy or downstairs boy? Y is always what? Upstairs. So Y is the amount saved. And what's X? Number of tickets, right? Number of tickets. So it's a little different. It's not about months this time. This one's about tickets. Let's jump the domain for a second and go to the range. What kind of numbers make no sense for how much they will pay for these tickets? Negatives make no sense. Are we cool with that? Does 0 make sense? What if I chose not to buy the tickets? Wouldn't that still be $0, right? So 0 does make sense. And then probably positives. Now I do agree. I'll talk about that when we get to the main. Let's just call it this. Y greater than or equal to 0 still. Are we okay with that? How come I chose the letter Y instead of X? Range is always going to be Y's. Cool. But how about the domain? Number of tickets. Negative tickets. Can they buy negative tickets? Nope. 0 tickets? Yes. Positive amount of tickets? But this makes sense. 1.5 tickets? 1.7 tickets? Shouldn't it be 1 ticket, 2 ticket, 3 ticket, 4 ticket, like whole numbers? Are you with me on that? We are smart enough to know that, but the homework system doesn't care about, like we know it's going to be a whole number amount of tickets. We're still going to say that X is going to be greater than or equal to 0, right? But our brains know, it's like, well, not every X value bigger than 0 is going to work. Like 1.2 doesn't work. And we could like maybe put in parentheses like whole numbers, but the homework program is not going to ask that. Does that kind of make sense? So it's just whole numbers. And the same thing goes with your range, you know? It's like, honestly, you would not have every Y value possible. Like there's no way you're spending $3. Are you with me on that? There's no way you're spending $3 because you're immediately going to have to spend a minimum of $63 plus $20. You know, it's like the smallest you could pay is $83 on that one. You know what I'm saying? But we're just trying to say, bro, positive numbers make sense, and so does 0. Is that okay? So, all right, let's write 2 equations. Let's go StubHub. Y equals, what's the slope for StubHub? $65 per ticket. And that startup fee is that one-time fee, right? So that's your y-intercept. So that's going to be plus 10. That's going to be plus 10. Get you a Ticketmaster equation real quick. $63 per ticket plus $20, right? And notice the question is a little different. It doesn't say when will they be the same price. It says when would it make sense for Lauren to buy from Ticketmaster, right? So what we will do, though, is just figure out first when they will be the same price. Does that sound okay? How will we do that? Solve this system by substitution, box and parentheses. So 65x plus 10 should equal 63x plus 20. And then we'll solve that. So 2x plus 10 equals 20. 2x should equal 10. And see if you get what I got. Could you tell me what label goes on that, by the way? It's about X, right? So you already have that figured out. If you just look back, what does X stand for again? Tickets, right? So what we just figured out was if they needed 5 tickets, it doesn't stinking matter which website you buy it from. It's going to be the same price. Are you with me? It doesn't matter, right? So when would you need to buy from Ticketmaster? You just have to do some mental thinking. Like there's no math to show on it. Tell me about Ticketmaster. Per ticket, is it more expensive or less expensive? It is less expensive per ticket. So what would that mean to you if I needed 6 tickets or 7 tickets or 8 tickets? Would you rather buy from Ticketmaster or would you rather buy from StubHub? When you know they're the same, it's at 5 tickets, right? Who would you buy from when you need more? The cheaper one or the more expensive one? The cheaper one. Which one's cheaper per ticket? Ticketmaster, right? So the question is, after 5 tickets or before 5 tickets, when would you buy from Ticketmaster? So when she needs more than 5 tickets. When she needs more than 5 tickets. That's kind of weird. That's kind of weird, right? When she needs more than 5 tickets. Because the ticket price is cheaper in that case. It was better to go from StubHub if you needed less than 5 tickets, because even though the ticket price is more expensive, what's cheaper? This guy, right? Isn't it that startup fee? Like imagine you needed 1 ticket. 1 ticket, StubHub, costs $75. Ticketmaster costs $83. 2 tickets, it would be cheaper on StubHub. 3 tickets, it would be cheaper on StubHub. 4 tickets, it would be cheaper on Stub. 5 tickets, same price. 6 tickets, now we got to go to Ticketmaster. Are we okay with that? It's kind of weird, right? All right, let's try one more, baby. I'll let you read that with a neighbor. It's not an easy thing to read. So in class, it seemed like we did a good job of reading it and reading. Like you got to read the little ad over here too, right? You know, that kind of gives you a bunch of information. We found the word per. Are we okay with that? I heard that, right? So can we define our variables? It's 40 cents, which is still in dollars. You know what I mean? It's actually like $0.4, right, which we call cents, you know. So 40 cents per what? Per gallon. So since dollars is upstairs, that is which letter? That is Y, and then X is gallons. So are we cool with gallons of gas and price in dollars, right? I think we could have done that just fine without me helping you. I think we could do the domain and range just fine without me, without helping you. Let's talk domain. Gallons of gas. Can you buy negative gallons of gas? Nope. Can you buy 0 gallons of gas? Yes. Can you buy positive gallons of gas? Yes. So that would be X greater than or equal to 0. The range is price. No negatives, right? You can spend $0 and you can have positive dollars, so are we cool with this? Don't get in a bad habit of thinking the domain and range is always going to be that. It will change as the stories change, but today, yes, it's going to kind of be like that. Does that sound okay? Right, 2 equations for this situation. This is where we might need a little help. I'm going to let you try without me, and then I'll fix some things if we need it. Can you figure out what it would cost without a car wash and what it would cost with the car wash? Give it a shot. Let's see how we did. If we messed up, totally cool. If I do not buy a car wash, how much does it cost per gallon of gasoline? Right here, $2.80. I'm going to put the 0 just because that's how money works, you know, times X, right? Plus how much? I did not buy a car wash. How much did you pay for the car wash if you did not buy the car wash? 0. So I am not going to put plus 0. Are you with me on that? It's just, bro, you fill it up, however many gallons you got, take 280 times it. Cool? All right, there's a catch, though. Like, if you buy the car wash, is everyone cool? That's going to cost you $8, right? But what do they do for you? 40 cents off, right? So instead of $2.80 a gallon, it is how much? $2.40 per gallon. Anything else since we bought this car wash? Plus 8. Right? Because you had to buy the car wash for $8, but you save 40 cents per gallon. Here you go. How many gallons of gas do you need to buy before either deal to cost the same price? Please solve that system of equations. We'll do it by substitution. Yeah. Subtract that over. 40 cents difference per gallon to equal 8. So I subtracted 240x from both sides, right? You know, cool. And then I need to do 8 divided by 0.40, or just plain old 0.4. What did we get for x on that? Cool. Could you put a label on it for me? It's the same thing that you labeled in your x's and y's before. What would that be? 20 what? Gallons. Yeah, you can leave off the I appreciate that, but 20 gallons. Are we cool with that? 20 gallons. That answers this question. I'm going to change the question. The question asks, how many gallons do you need for them to be the same price? 20 gallons. Here's my question. When is it a better deal to buy the car wash? Discuss with your neighbor. When should you buy the car wash? It would make more sense to buy the car wash if you needed more than 20 gallons of gas because it is cheaper per gallon. Let me know if you have questions. Have a good one.